So in algebra review, we're going to talk about solving inequalities because this is going to pertain to what we talk about later in chapter 5. So solving inequalities is almost identical to solving equations, except if you multiply or divide both sides by a negative number, the inequality symbol flips. So we're going to solve inequalities like this one, negative 6x plus 7 greater than 25. Just like solving equations, our goal is to isolate the x. Okay. If you have variables on both sides of the inequality, try to combine those to one side first. We do not. So we are just going to try to isolate the x on the left-hand side. So our first step is subtract 7, which leaves us with negative 6x greater than 27, or 25 minus 7 is 18. And then what do? So we're going to divide both sides by negative 6. So x, so because we divided by a negative 6, I'm not going to do a greater than symbol. I'm going to do a less than symbol. And 18 divided by a negative 6 is negative 3. So what this means is that if we, as long as we plug in a number for x that is less than negative 3, so negative 4, negative 5, negative 6, negative 7, negative a million, we will get a true statement. If we plugged in a number larger than negative 3, like 0, we would get a false statement. Okay. Because if you put in 0, you would get 7 is greater than 25, which is false. If we put in negative 4, we would get negative 6 times negative 4 would be 24. 24 plus 7 would be 31, which would be greater than 25. So that's what we're solving. So we're going to solve 3x minus 5x plus 2 is less than 12. Which we could rewrite as 3x plus negative 5x plus 2 is less than 12. Whenever you're solving an equation or an inequality, simplify each side of the equation or inequality, so on both sides of the sign. Simplify by combining like terms first. So if we look at the left side of this inequality, we have 3x plus negative 5x. What does that give us? Negative 2x plus 2 is still there, less than 12. What's our next step in solving? Subtract 2 from both sides. So negative 2x is less than 10. So divide both sides by negative 2. Switch the sign, very good. So x is greater than negative 5. Now, how could you test to see if that answer was correct? Yeah, plug in a number that's relatively close to this, but bigger than -5, so like -4, and see if it works. We could even do it right here after we simplified. -2 times -4 would give us 8. 8 plus 2 would give us 10. Is 10 less than 12? Yes. So our answer should be correct. So if you have it set up with the variable on the left, the inequality symbol will basically work like an arrow. As long as the variable's on the left, if it's greater than, your arrow should point the same direction as the inequality symbol to the right. If it's less than, then you're unequal. Now, if your variable is on the right, that totally messes that whole thing up. But if your variable is on the left, your inequality symbol will give you an indication. If you have a less than or a greater than without any line underneath it, it is going to be an open circle at that number. If there is a line underneath it, we do a closed, we do a dot, filled in dot at that number of -5, and then we would go.